So we're looking at solving systems of linear equations by graphing. So first, if you think of a system of linear equations, you're going to have two or more linear equations, something like that. So I have two linear equations, and if you think of those on the same x and y axis, then there ends up being three different possibilities that we could have. The first possibility is when you graph these, they intersect at one point. That intersection is the solution to the system. It's the x and y value that satisfy both of the equations in the system. A second option is that the two lines that we have end up being parallel. If the solution to a system is where the lines intersect and my lines end up being parallel, then we end up having no solution. And the third possibility is that I end up with the same exact line. So we could have two equations in the system, but one could just be like a multiple of the other one. In that instance, we would have just one single line. In this instance, you have 2, 3, however many lines, and they all end up being the same line. So if our solution is the point of intersection, this line intersects itself at every single point, so we have an infinite number of solutions. So here are the three possibilities that we have, and again, we're solving by graphing. So I'm going to start by getting a system. So let's look at an example. So let's say I have 1/2 x minus 2/3 y is equal to 5/3, and 1/3 x plus 1/5 y is equal to 7/15. So I want to solve this system by graphing, which means I want to find the pair of x and y values that satisfy both equations. One way to do this is, of course, we're graphing, so we can either put it into slope-intercept form and graph using the y-intercept and slope, or put it in y-intercept form, and you could go to desmos.com and graph them and see if they have an intersection and what point they intersect at. Another option is to graph them by their intercepts, so finding the x and y intercepts, which is what I'm going to do here. I know nobody really enjoys a whole lot working with fractions, so I'm going to start by getting rid of my fractions. So looking in the first equation, I have denominators of 2 and 3. So the common denominator there would be 6, so I'm going to multiply everything in that equation by 6. When I multiply by 6, 6 times 1/2 is 3. 6 times 2/3 gives me 4, so minus 4y equals 6 times 5/3 is 10. And so by multiplying by 6, I got rid of all the fractions. So now it's not so ugly to look at. And I'll do the same thing with the second fraction. I have denominators of 3, 5, and 15, so the common denominator here would be 15. So I'm going to multiply everything in there by 15. 15 times 1/3 is 5. 15 times 1/5 is 3. And 15 times 7/15, I'm multiplying by 15, dividing by 15, so those cancel out and give me 7. So I got rid of my fractions, and like I said, I want to graph this just by finding the x and y intercepts. So if you recall, to find the x-intercept, I'm just going to plug in 0 for my y value, and to find the y-intercept, I'm going to plug in 0 for the x value. So I'll start with the first equation, so equation number 1. To find the x-intercept, I'm plugging in 0 for y, so I get 3x minus 4 times 0 equals 10. And now I'll just solve for x, so negative 4 times 0 is 0, so I get 3x equals 10. Divide both sides by 3, x equals 10/3. So my x-intercept is 10/3, comma 0. And for the y-intercept, I'm plugging in 0 for the x value. So I have 3 times 0 minus 4y equals 10. 3 times 0 is 0, so I'm left with negative 4y equals 10. And to get y all by itself, I'll divide both sides by negative 4. So I get y is equal to negative 10 over 4, which reduces to negative 5 over 2, or negative 2.5. So the y-intercept is 0, comma, negative 5/2. And so I'm going to go ahead and graph that, and then we'll look at the second equation. So if I'm graphing this by hand, I do need to be very precise, or at least try to be. So when we're looking for the intersection, I have a good general idea. So 1, 2, 3, 4, 5, 6. And if you have graph paper, that'd probably be ideal. Alright, so my first equation, we found that it had an x-intercept of 10/3, so that's 3 1/3, so right about here, I suppose, and a y-intercept of negative 5/2. I'm going to bring that down. A y-intercept of negative 5/2, which is negative 2.5, so I'd be somewhere right about there. And I'm going to use this paper to try and get a good straight line. There we go. Alright, so there's one of my lines. I'm going to go ahead and go back to the other equation. So it's taking equation 2 now, and again I'm going to graph this by finding the intercepts. So to find the x-intercept, I'll plug in 0 for y. So I'll have 5x plus 3 times 0 equals 7. 3 times 0 is just 0, so I have 5x equals 7. So x equals 7/5. So that coordinate is 7/5, comma 0. And to find the y-intercept, I'm just plugging in 0 for the x value. So I have 5 times 0 plus 3y equals 7. 5 times 0 is 0, so I get 3y equals 7. So y is equal to 7/3. And that coordinate is 0, comma 7/3. So now I'll graph the equation, the line of the second equation, just by using the coordinates. So 7/5. So 7/5 is 1.4. So 1.4, right about there. And 7/3, 0.7 is my y-intercept. So 7/3 is going to be 2 1/3. So 2 1/3, right about there. And again, try to get it as close to straight as possible. And when we're pretty precise, we can see that these two lines cross right about 2, -1. So if I had to guess, the intersection would be 2, -1. So the solution to the system is 2, -1.